Hello, everyone. In this guide, we'll explore how to diagnose and fix Kafka consumer connection issues in Java, specifically focusing on problems that aren't fully solved in Stack Overflow or other common resources. This implementation will demonstrate how Java's networking behavior can cause Kafka consumers to fail, how Maven dependency resolution can break, and how to systematically resolve these issues. To start with, let's understand the root cause. The fundamental problem stems from Java's default IPv6 preference with respect to Kafka consumers. On systems with IPv6 enabled, Java prefers IPv6 when both IPv4 and IPv6 stacks are available. This preference exists even if a hostname resolves only to an IPv4 address. Java may attempt IPv6 connections first, which can cause significant delays or complete connection failures before falling back to IPv4. First, let's examine why Maven dependency resolution fails. Maven uses Java's networking stack to download dependencies from remote repositories, such as Maven Central. When Java tries IPv6 first, several problems can occur. The IPv6 connection attempt may time out before Java falls back to IPv4, causing the entire download to fail. Even if IPv6 is configured, the delay in attempting IPv6 and then falling back to IPv4 can result in slow or failed downloads, especially when Maven has cached previous failed attempts. Next, let's understand why your Kafka consumer fails with the specific error, connection terminated during authentication. This error occurs because Java attempts an IPv6 connection first, even if the Kafka broker has no IPv6 address configured. The IPv6 connection attempt hangs or times out, consuming valuable connection time. By the time Java falls back to IPv4, the connection may be in a bad state, with authentication handshake timeouts or failures. The connection state becomes corrupted, preventing successful authentication even when IPv4 connectivity is available. This is a known issue with Kafka clients in dual-stack networking environments, documented in Kafka issue KAFKA-6444. Now let's look at why the system property prefer IPv4 stack equals true fixes these issues. This JVM system property forces Java to use IPv4 only, completely avoiding any IPv6 connection attempts. By preventing IPv6 attempts, we eliminate the timeouts and connection state issues that occur during the fallback process. This ensures direct IPv4 connections to both Kafka brokers and Maven repositories before executing any Maven command. You can add the line export Maven opts Java.net prefer IPv4 stack true to this file. This provides a user-specific Maven configuration that applies to all Maven projects you work on. Now let's examine the specific error messages you might encounter. When your Kafka consumer fails, you'll see warnings like connection to node -2 terminated during authentication and bootstrap broker disconnected. These messages indicate that the connection was established but failed during the authentication handshake. The error message suggests 3 possible causes: invalid credentials with older brokers, firewall blocking Kafka TLS traffic, or transient network issues. However, in our case, none of these are the actual problem. The real issue is the IPv6 connection attempt, causing the authentication handshake to fail or time out. Let's look at common errors when connecting to a Kafka broker and how to fix them systematically. The first category of issues involves trust store and key store problems. If you're using SSL or TLS to connect to Kafka, you need to properly configure the trust store and key store paths in your consumer properties. The trust store contains the certificates of certificate authorities that your application trusts, while the key store contains your client's certificate and private key if client authentication is required. Common errors include file path issues, incorrect password configuration, or missing certificate files. To diagnose these, you can enable SSL debugging by adding -d javax.net.debug equals SSL to your JVM arguments, which will show detailed SSL handshake information. The second category involves Maven cache build errors. Maven caches metadata and artifacts to improve build performance, but this caching can cause problems when previous connection attempts failed. Maven had cached a previous failed attempt to download plugin metadata, resulting in a broken pipe error. Maven will reuse cached failure records until the repository update interval elapses, unless you force updates. To fix this, you need to remove or move the cached metadata and force updates. The cached metadata is typically stored in meta directory. You can delete this directory or specific failed metadata files. Additionally, you should use the -u flag with Maven commands to force updates, which tells Maven to check for updates regardless of the update interval. For some environments, forcing IPv4 avoids intermittent SSL or TCP handshake issues that manifest as broken pipe errors. To resolve Maven cache issues, you should use the IPv4 preference flag combined with force updates. For dependency resolution, run this command. If you continue to get network errors, force the IPv4 parameter every time you run Maven commands. This consistently works and prevents the IPv6 connection issues from recurring. For advanced debugging, you can enable authentication debugging by adding -d Djava.security.auth.debug equals all to your JVM arguments. This will show detailed information about the authentication process, including which authentication mechanisms are being attempted, what credentials are being used, and where the authentication process fails. This is particularly useful when diagnosing connection terminated during authentication errors, as it will show you exactly which step in the authentication handshake is failing. There's an important concept to understand about how Java programs work. When you run a Java program, you are actually starting a JVM instance. That JVM instance will have its own system properties, which is where you have to put your property. When you run another program, that will have its own separate JVM instance with its own system properties. You cannot expect a property which you set in one JVM instance to be accessible from another JVM instance. This is a fundamental aspect of Java's process isolation. Each JVM instance is completely isolated from others, with its own memory space, system properties, and runtime environment. You can access system.getProperty, open parenthesis, property, key, close parenthesis in all classes running within the same JVM instance. This means if you set a system property when starting your Kafka consumer application, all classes in that application can access it. However, if you set a property in a Maven build process, that property is only available to the Maven JVM instance, not to the JVM instance that runs your Kafka consumer application. This is why you need to configure the IPv4 preference, both for Maven commands and for your application runtime. Let's create a comprehensive troubleshooting checklist for other issues. First, verify your network connectivity by testing if you can reach the Kafka broker using telnet or nc commands. This confirms that basic network connectivity exists. Second, check your DNS resolution by running nslookup-broker1.io or digbroker2.io. This shows you what IP addresses the host name resolves to and whether IPv6 addresses are present. Third, verify your Java version by running java-version and check if IPv6 is enabled on your system using your operating system's network configuration tools. The key takeaway is that dual-stack networking environments, combined with Java's IPv6 preference, create connection issues for Kafka consumers. Java tries IPv6 first, which fails or times out, and by the time it falls back to IPv4, the connection state may be corrupted. The solution is simple, but must be applied consistently. Always use -d java.net.prefer IPv4 stack equals true for both Maven operations and your Kafka consumer application. This forces Java to skip IPv6 entirely and use IPv4 directly, avoiding all the timeout and state corruption issues. In summary, we've covered the root cause of Java's IPv6 preference in dual-stack networking environments. why Maven dependency resolution fails, why Kafka consumer connections terminate during authentication, and why the IPv4 preference system property fixes these issues. We've explored multiple solution approaches, from global Maven configuration to application-specific settings. We've examined common error categories, including trust store and key store issues, Maven cache problems, and Java system properties configuration. We've provided a comprehensive troubleshooting checklist to systematically diagnose and resolve these issues.